Good morning. Today we will start the second unit. In second unit, it deals totally on aggregate, quality of water, and the steps in manufacturing of concrete, and finally curing. So, in today's class, we will see about classification of aggregate. Aggregates plays a major role in creating the volume for the concrete. So 60 to 80 percentage of the volume of concrete is occupied by aggregate. So the main significance or the purpose of adding aggregate is that it should be economical. If you use cement only, okay, you know the costliest material among the different ingredients of concrete is cement. So now to reduce that cost, we are adding in a cheaper material. That too, it should be an inert material. It should not react with the cement and other water, so that we are choosing this aggregates, and it should form in dimensional stability. It should not shrink. The shape which I have decided for the concrete should not change once after the curing is completed, and also the aggregate should have strength and stiffness. It should not break easily, and also it should have abrasion resistance. Abrasion means the surface wear and tear should not happen. It should be strong enough to withstand that the wear and tear happening to its surface. Okay, so this is a picture where the abrasion resistance is happened to a concrete pavement. Here you can see aggregates are clearly visible due to the continuous movement of the traffic load, but you can see some aggregates are showing the resistance only the surrounding cement mortar has been separated out. Okay, so regarding the extraction of aggregate, as you already know, aggregate main source are the mountain rocks. So what they will do means they will construct a quarry near a mountain, and by using some explosives they will break the rocks into small pieces, and then they will load it in truck, and then it is sent to the quarry where the sieving will be done, screening will be done, and then it is crushed by a jaw crusher. Further it is broken down, and if you want in chips means, further it is sent to uh, another process called secondary crusher and tertiary crusher, and then sieving is done. Different sizes like 20 mm, 10 mm, chips of 6.5 or 7 mm, like the different sizes will get, and it will be transported based on the requirements. So next we will see the classification of aggregate. So aggregates are classified based on the geological origin, size, shape, unit weight, texture. We'll see one by one. So geological origin means you already studied about engineering geology. Rocks are classified under three major classification based on its formation. One is igneous, sedimentary, and metamorphic rocks. So igneous rock, how it is formed, the molten lava from the core of the earth. Once it comes out, okay, through that volcano, it just erupts, and then this molten larva will spill out. Suppose the if that molten material is inside the mountain itself, it is called magma. Once it comes out and then spills along the surface of the mountain means it is called lava. So once it finally cools down, then the rocks has been formed. So this is the purpose. So cooling down of hot molten magma. So this one will have crystalline and glassy texture in that. It will be light in color, it will be dark in color. Moreover, it is very odd, dense, and some of the materials are granite, basalt, and dolerite. Next one is sedimentary rocks. So sedimentary rocks are formed by deposits in layers. So if any mountain is there, due to the weathering process, what will happen? It will break into small pieces, and along the direction of the water, rainwater flows, this also will try to erupt, and then it will be deposited under the river beds. So slowly it will try to compress, and it will form these sedimentary rocks. Sedimentary rocks will be identified by its formation of layers, and moreover the strength is somewhat low when compared to the igneous rocks. So some of the examples are this gravel, limestone, sandstone, shale, and conglomerate. So these are all flaky aggregate. Flaky means it will have a flat shape. That means one thickness will be less, so that it can be easily breakable, and it is not much recommended for concreting. Next one is metamorphic rock. So metamorphic rocks are formed. So when this igneous rock are subjected to pressure and heat, it will compress both the igneous and sedimentary rock. Okay, under this pressure and heat, it will change to metamorphic rock. You can see an foliated structure. Sedimentary rock will have parallel texture. This one will have foliated. Okay, undulations you can see in this picture clearly. Okay, so some of the example of nice. Now we will discuss about the size. Okay, size is determined based on the particle size distribution. There will be different set of sieves. IS sieves are there. So if we pass the aggregates in that, based on the different sizes of the particle, it will be retained on those sieves with the marking denoting its size. Normally we will have 80 mm, 40, 20, 12.5, 10, 7.5, or 6.7, 4.75, like that. The sets of C's will be there based on the IS standards. So from that we can determine the size of aggregate. So for a concrete, for a good quality concrete, we should go for a graded aggregate, where the aggregates should have uniformly retained aggregate in all the sieves. Okay, so based on the size, there are four classification. One is fine aggregate, coarse aggregate, all in aggregate, and single size aggregate. Okay, so fine aggregate means, so whichever is passing 4.75 ISU is called fine aggregate. Normally the sand, okay, and M sand will come under this classification. So nowadays, due to the shortage of river sand, we are going for M sand, which is nothing but a manufactured sand, which is produced by a process of crushed stone dust. Okay, so next we will see about coarse aggregate. So whichever is retained on 4.75, so the fine aggregate is passing 4.75, and coarse aggregate means it is retained on 4.75. So this also will come under crushed gravel as well as uncrushed gravel. Next one is all in aggregate. All in aggregate denotes both fine aggregate and coarse aggregate combined together. And next one is single size aggregate. Single size aggregate means it will be having one size. So 20 mm means all the aggregate will be 20 mm. It will be uniform in size. Okay, next one is classification based on the shape. Based on the shape, it is classified as round aggregate, irregular or partially round, angular, flaky, and elongated. So these are all the different pictures which shows the shape. So round aggregate means it will have the absence of sharp edges. The voids involved in that will be 32 to 33 percentage. It will have good workability. As it has no smooth edges, the workability will be very good, but the interlocking will be very poor, and it is not suited for high strength concrete. Next one is irregular aggregate. Irregular aggregate means it is a in between stage between an angular aggregate and a round aggregate, where the edges are not that much sharp and not that much smooth. So it is partially round. So it has higher voids of 35 to 38 percentage. It will show better interlocking when compared to the round aggregate. Next one is angular aggregate. Angular aggregate have the sharp edges, but the workability will be somewhat less. It has more voids in it, and it is suitable for high strength concrete due to the better interlocking, and we can't ensure a good workability in that. And next one is flaky aggregate. So flaky aggregate means any one dimension will be less than 3 by 7 times of its mean dimension. So if there is more number of flake aggregate, that means 100 if 100 percentage aggregate is there, more than 15 percentage flake aggregate is there, means then it is not recommended. The aggregate lot should be rejected. Why means it will easily break and strength will be reduced. And next one is elongated. Elongated aggregate means any one size will have longer dimension. That means whose greatest dimension, okay, if it is longer than 9 by 5 times or 1.8 times of the mean dimension. So if you use this one, it also reduces the workability and strength also will be affected. So as of the previous case, its maximum size also, maximum percentage should be restricted to 15 percentage. Next one is based on the texture. Based on the texture, okay, it is classified as glassy, smooth, granular, crystalline and honeycomb. So glassy will have sharp edges and smooth means it is denoting an gravel. Granular means it will have a lot of small pores in that. Crystalline means we can see the crystal patches in that clearly. And then last one is honeycomb or porous, which will absorb a lot of water. So normally these are all the pictures which is showing a glassy aggregate which is very shiny. Next one is smooth, this third one is granular, this one is crystalline, and this one is honeycomb. Okay. And what type of aggregate based on the texture preferred is crystalline aggregate, because crystalline only will have a rough texture, so that better interlocking will happen when compared to other textures of aggregate. In glass aggregate, the bonding won't be happening between the cement paste and the aggregate. Suppose if it is more honeycomb and porous means it will absorb all the water which is used for making the concrete and the hydration process. So preferably we should go for crystalline aggregate. Smooth also won't have a proper interlocking. Last classification is based on the unit weight. Based on the unit weight, it is classified as normal weight, heavy weight and light weight. So normal weight aggregates are aggregates which is obtained from granite, basalt, quartz, sandstone and limestone. Its unit weight will be between 23 to 26 kilonewton per meter cube. And the second one is heavyweight aggregate. So this type of aggregate are used for some special applications. For example, okay, if there is a nuclear thermal power plant, for example, this IG car in Kalpakam, there and all, to prevent the radiation to expose to the atmosphere, that reaction unit should have a strong concrete which should not allow radiation to pass through. So in those cases we can go for this heavyweight aggregate. Barite, geotite, magnetite and iron start also used. So where its density is very much higher and also the strength also will be more. Okay, since it is of high weight, it also won't be providing good workability, but the radiations can be prevented in that. Last one is lightweight aggregate. So wherever the unit weight of aggregate is less than 12 kilonewton per meter cube for fine aggregate and 10 kilonewton per meter cube for coarse aggregate, it is called as lightweight aggregate. Mostly for partition walls where I want to reduce the self weight, uh, I can go for this lightweight aggregate. Moreover, it has good thermal insulation and also fire resistance also. So naturally that dolomite, that vulcanese, cinder, pumice and all will come under this natural. Sometimes this aggregates, lightweight aggregate also manufactured. Bolted clay, cynated fly ash, okay, vermiculite, like that. Many manufacturing artificial lightweight aggregates also there. So the main advantage is that it will provide thermal insulation and also it will provide fire resistance also. Thank you.